Standard 6th, Subject Maths, Chapter 4, Operations on Fractions, Part 1. So let's begin with our new lesson, that is Chapter 4, Operations on Fractions. Now my dear students, operations on fractions, these two words, that is operations and fractions. What are operations in mathematics? So the basic operations in mathematics are addition, subtraction, multiplication and division. Okay. Now what are fractions? Fractions are a part of a whole. So when we are talking about a part of a whole thing, okay, it is a fraction. Now what is a whole thing? For example, look at this circle. This circle is a whole circle, okay. So this is one full part. When we divide this circle into two parts, two equal parts, okay, this each part becomes half. So this top, what you can see, is half, and below also is half. Okay, so when we are talking about only the top part, which I am shading now, okay, so this becomes the half. Half means from the full we are taking this half part. So this full we have divided into two parts. Okay, so how we write half? Out of two parts, 1. Okay, so 1 out of 2, and therefore it is written as half, 1 upon 2. Now further, that same whole, okay, if we divide in 4 equal parts, okay, if we divide into 1, 2, 3, 4, 4 equal parts, then each part, okay, the part which I am shading, if we are talking about this one part here, this small part which I am shading in green, it is called as 1/4 of 1/4 means from this whole we have divided into 4 parts. So out of 4 parts we are talking about this one part, and therefore we write it as 1 upon 4 or 1/4. So out of the 4 parts, one part. And the next is 3/4. What is 3/4? Now the same circle which we had divided into 4 parts, if we take 3 parts out of this, which you can see in white color here, which are not shaded. So here I have drawn the same thing. So these are actually the 3 parts. So this is here, if I just put some dotted lines here. So this is one part, second part and third part. So this full, what is shaded, is actually the 3 parts from the 4 parts, and therefore it is written as 3/4. In this way we write a fraction when we describe a part from the whole. Okay, moving further, just an example here, that is, if there are 5 children, 3 out of 5 children are girls. Okay, what is a fraction of girls? If we have to write the fraction of girls, so how many girls out of the whole are, or all the children are girls? So 3 children out of 5 children are girls, and therefore the fraction of girls become 3 upon 5. Okay, so since 3 children out of 5 children are girls, and therefore the fraction for girls will become 3 upon 5. So we write the part upon the whole. Okay. There's another simple example here. If there are 10 balls, 6 out of 10 balls are red balls and others are green balls. Then we have to write the fraction of red balls and fraction of green balls. Okay. Now, how many are total balls? There are total 10 balls. Out of that, 6 balls are red color. So the fraction for red balls will be 6 balls out of the total balls are red. So 6 upon 10 is the fraction for red balls. Now green balls, they have not given how many are green balls, but the remaining are green balls. So out of 10, if 6 balls are red, naturally remaining is 10 minus 6, 4 balls are green. Correct? Now if 4 balls are green out of 10, so the fraction for green balls we'll write 4 upon 10. Okay, so apart from the whole. In this way we write a fraction. Now after this, now if we have to share something between a given number of things. Okay, there is an example here. I have drawn some chocolates. Okay, so these are sweets. 1, 2, 3, 4, 5, 6. There are 6 sweets here. So divide this 6 chocolates among 3 children. Okay, so what we'll do, we'll take all those 6 chocolates and we will divide among 3 children, giving 1, 1, 1 to each. Okay, and what do we end up? Okay, you can do this at home actually. That is, you can hold 6 chocolates in your hand and you will divide it between 3 people. So at the end you will find that each one is getting 2 chocolates or 2 sweets. How? So these 2 sweets you will give one person or one child. These 2 sweets to another child and these 2 sweets to the third child. Now how you will solve this? With the help of fraction. Now if there are 6 chocolates and we have to share it among 3 children. When there is a question of sharing, okay, now here there is a sharing of 6 chocolates among 3 children. So remember, whenever there is a sharing, what thing has to be shared should be in the numerator. Okay, now you all have studied fraction earlier, so you all know what is the numerator part and the denominator part. If not, I will just revise. Just now we saw the fractions. So here, if 1 upon 2, if this is a fraction. So a fraction has a numerator and a denominator. The digit which is in the numerator, the number which is in the at the top is the numerator, and the number which is down is the denominator. So in this case, the numerator is 1 and the denominator is 2. So if we see this here, 3 upon 5, this is a fraction. It is said as 3 upon 5. Okay. And what is the numerator here? The number which is at the top is the numerator. So 3 is the numerator, 5 is the denominator. This is a fraction 6 upon 10. 6 is the numerator, 10 is the denominator. 4 upon 10. 4 is in the numerator, 10 is in the denominator. I hope you have understood or you have revised. Now coming back to this. As I told you that the number what has to be shared always comes in the numerator. Now if we have to write the fraction and solve this particular thing with the help of fraction. So 6 chocolates we have to share. So as I told you, whatever we have to share has to be written in the numerator. So 6 chocolates what we have to share I have written in the numerator upon 3. Okay, so the fraction becomes 6 upon 3 equal to. Now we will solve this. You can do this directly here by cancelling, or you can do it in the rough. So we know that 3 ones are and 3 twos are. So we get 2 upon 1. Or you can do it here also, 3 and 6. So 3 twos are 6. So the answer is 2. So what is the answer? 2. So if we divide 6 chocolates among 3 children, each child will get how many chocolates? Will get 2 chocolates. So always remember, when it is a question of sharing, what has to be shared should be written in the numerator. Okay, so here 6 chocolates had to be shared. So 6 chocolates, 6 number is written in the numerator. The other number is written in the denominator, and you can solve it and you can get the answer. So this was just a small example so that you understand how do we write a fraction. Now coming to types of fraction. There are 3 types of fraction: proper fraction, improper fraction, and mixed fraction. Now what is a proper fraction? In a proper fraction, the numerator is less than denominator. So whichever is the number in the numerator and the numerator should be less than the denominator. So examples, there can be many examples. Just I'll write 2-3 examples. So 2 upon 9, 12 upon 16, 3 upon 5. So in all these cases you will see the numerator and the denominator, if you observe, the numerator is smaller than the denominator. Numerator is smaller than the denominator, even in the third. And in this way you can write many other examples. So this type of fraction where the numerator is smaller than the denominator, it is called as proper fraction. Now what is improper fraction? The numerator is more or equal to the denominator. Okay, so here it can be 7 upon 4, 3 upon 2, 12 upon 5. So, and it can also be equal. For example, 13 upon 13. So these are improper fractions where the numerator is greater than the denominator. So in this case, the fraction is 7 upon 4. The numerator is greater than the denominator. 3 upon 2, numerator is greater than the denominator, even here. And or it can be that the numerator and denominator both are equal. So it's an improper fraction. And the third is a mixed fraction. So what is a mixed fraction? A fraction which has a whole number along with a proper fraction. Just now we studied what is a proper fraction. A proper fraction, the numerator is less than the denominator. So in mixed fraction, we have a whole number. Whole number is any number, 1, 2, 3, 4, 5, 6, any number which is a whole number which doesn't have a numerator and a denominator, or whose denominator is 1. Okay. So I can write 7 and a proper fraction. So it can be 1 upon 3. So it has a whole number 7 and it has a proper fraction. The numerator is less than the denominator. And this is a way of writing it. You write the whole number and then you write the fraction. Okay. There can be many examples, etc. Okay. So a whole number and a improper fraction where the numerator is small and the denominator is greater. Just go through this before we proceed. Okay, now we'll see the textbook, page number 22. The first exercise here, practice set 9. Okay. Now, what does the practice set 9? The first question here say, convert into improper fractions. Now here you will see these are all the examples of mixed fraction. Okay, a whole number and a proper fraction. Okay, now we have to convert these mixed fraction into improper fractions. So we'll start. Here the first one, 7 2 upon 5. Now there are two ways of solving this. I will show you both the ways. It is up to you which method you want to solve. Okay, both are correct methods. So the first method is, this is said as 7 2 upon 5. The whole number and a proper fraction. Now what we do is, we split this whole number and a proper fraction with a addition sign. So what we write is 7 plus 2 upon 5. Okay. Now after we split this, as I told you, what is a whole number? A whole number is a number which has no numerator or the denominator. If it is there, it is 1. So in a whole number, the denominator is 1. So I put 1 here. Okay. Now, after this, so the first step is to split the whole number and the fraction. Okay. And after that, below the whole number in the denominator, we'll put 1. Now the next step is to equalize the denominator. If you see, the denominators are same of both. 7 upon 1 and 2 upon 5. So the denominator is 1 and 5. Now we have to make the denominator same. So now if we have to make the denominator same, which denominator we can convert? If you see 1, can we convert 1 to 5? Is it possible to convert 1 to 5 if we multiply by any number? Yes, if we multiply 1 with 5, we get 1 5s are 5. But if we are multiplying in the denominator, the same operation we have to do in the numerator also. So if I am multiplying 5 in the denominator, I have to do the same operation in the numerator. So now what will be the next step? If 1 5s are 5, 7 5s are 35. So 7 5s are 35, I write here, upon 5 plus 2 upon 5. Now I got the denominators same. In fractions, when we are, you have studied in the earlier standard that when we are solving the sums like addition or subtraction with the fractions, okay, especially when we are doing addition and subtraction with fractions, their denominator should be same. Now since here we have got denominators same, we can add. Earlier it was not possible for us to add because One denominator was 1 and the other denominator was 5. In this case, we cannot add directly. So we will add here now in this second step because the denominators are same. So this becomes 35 plus 2. So this can be written, the denominators can be written only once and we can add 35 plus 2. And the answer is 37 upon 5. So this we have converted into improper fraction. The mixed fraction to improper fraction. I hope this is clear. This is the first method. Okay. Or you can write method 1. But when you are solving, you will not solve by both the methods. Which method is easier for you? You will solve by that method. I hope method 1 is clear. Now what is method 2? I will take the same sum. Okay. That is 7, 2 upon 5. Now the second method is when you have this mixed fraction, we have to multiply the denominator of the fraction with the whole number. So 5 multiplied by 7. And then we have to add the numerator of the fraction. So plus 2 upon the denominator. It's very simple actually. So the denominator multiplied by the whole number plus the numerator upon denominator, which is equal to 5 sevens are 35 plus 2. I am writing as it is upon 5, which is equal to 35 plus 2 is 37 upon 5. Okay. Both the methods are there in front of you. Now which method is easier for you? You all will do according to that method. This is not very difficult. This is very easy. Okay. We just have to multiply these numbers which is in the denominator and we have to just add the numerator upon the denominator. If you solve few sums, it will be easier for you to understand. Or you can choose this method. Any one method. Okay. When I am solving the further sums, I will solve by one method. You all can decide on your own. And please do not solve both the methods. First sum you all can write both the method where I have written just now. So the first sum you all solve by both the methods and the remaining sums then you all decide which method you all want to follow. Okay, I'll proceed. The second sum. Second sum is 5, 1 upon 6. Sorry. Here. So 5, 1 upon 6. Now I will solve this particular exercise with the first method. Okay. And then maybe the next exercise I will solve by the second method. So now here if you see, what is the first method? 5 plus 1 upon 6. We just split this with an addition sign. Okay. Now, denominator there is nothing. So that is 1. Now we have to convert this 1 to 6. Okay. If we multiply 1 into 6, we get 6. But whatever we do down, we have to do in the numerator also. So 5 multiplied by 6 becomes 30. 5 6 are 30 upon 6. Plus 1 upon 6. Okay. This step here, we have to see how we can make the denominators same. So which number you can multiply. Now 1 multiplied by 6, I got 6. But if I am multiplying 6 in the denominator, I have to do same operation in the numerator. So 5 into 6 becomes 30. Now since the denominators have become same, I can add the numerator. We can do the addition only after the denominators become same. So now 31 upon 6. Okay. Then I'll do the third one. 4, 3 upon 4. So here 4 plus 3 upon 4. Now nothing is there in the denominator of this 4. So there is 1. Now how we can convert this denominators to same number? We can convert 1 to 4 only if we multiply by 4. So we have to multiply 4 in the numerator also. So 4 into 4 is 16 upon 1 4 is a 4. And this other number will remain the same. Now we have got the denominators are same. So we can add the numerators. Okay. Now if we add the numerators, what we get? 16 plus 3, 19 upon 4. Okay, so this is the way we solve. I hope you have understood. It's very simple. Now homework. I've done the first, second and third. The fourth and the fifth sum will be for homework. Okay, same method we have to do. Now I proceed to the second part of this particular practice set. Convert into mixed numbers, that is mixed fraction. Okay, so you will see here they have given this fraction here 30 upon 7, 7 upon 4, 15 upon 12. Okay, so these are all improper fractions. We have to convert into mixed fractions. So we start. Here also first I'll do 30 upon 7. Now in this what we have to do is we have to actually carry out the division. So 7 divided by, so 7 is the divisor and 30 is the dividend. Okay, so how we'll do this? 7 4s are 28 because 7 5s are 35, which we cannot take. Okay, we carry this subtraction, sorry. This is a very simple one which we have studied maybe in the third standard, second standard, third standard. Now, after we complete this, we have got quotient as 4, remainder as 2. 7 is a divisor and 30 is a dividend. Now, after completing this division, you will write the answer. While writing the answer, the quotient becomes the whole number. Now, I'll just mention here, quotient is Q, which is 4. Remainder is 2. Then divisor is 7. And dividend is the number which we write inside. Dividend is 30. So when we are writing this as a mixed fraction, we write the quotient. Then we have to write the fraction, correct? So in the fraction, the remainder we write as the numerator. And the divisor we write as the denominator. So 4, 2 upon 7. Okay, so how do you write a mixed fraction? I can just write here. You write the quotient. Then you write the remainder upon the divisor. This is the way of writing the mixed fraction when we are doing the division or when we are converting the improper fraction to a mixed fraction. Okay, I'll do more sums so you will understand. 7 upon 4. You don't need to write all this every time. I have written only for first sum so that you understand. Even this you will not write. Okay, you will just solve this particular thing here. Okay, now I'll do the division. 4 divided by 7. 4 ones are 4, 4 twos are 8. 2s are 8 we cannot take. So this remains 4 ones are 4. We subtract. The answer is 3. Quotient is 1. Remainder is 3. And divisor is 4. We just need the divisor. We don't need a dividend. So how do you write? We write the quotient first. Correct, no? So quotient is 1. Then the remainder upon divisor. Remainder is 3 upon 4 divisor. Sorry. I hope you have seen this. 4 ones are 4. Remainder is 3. So now how do we write? Quotient remainder upon divisor. Quotient is 1. Remainder is 3 upon divisor 4. So quotient remainder upon divisor. Okay, third sum. 15 upon 12. Maybe you all do this for homework. Okay, then fourth sum and fifth sum also for homework. Okay, so third, fourth and fifth for homework. I'll do the sixth one. 20 upon 7. Okay, third, fourth, fifth for homework. Now here again division. 7 ones are 7, 7 twos are 14. We cannot take 3s are because it is 21. So 7 twos are 14. You just have to do simple subtraction here. Quotient is 2, remainder is 6, divisor is 7. So how do we write? We write the quotient, we write the remainder upon divisor. I hope this is clear. Okay, so now we proceed. After the division, you just keep this in mind. How do you write? Quotient, remainder upon divisor. But before that, you should know what is the quotient, what is the remainder. Quotient here, this is 4. Remainder is 2. Divisor is the number which we write outside or which is in the denominator. 7. We don't need dividend here. Okay, while making this mixed fraction. Now we proceed to the third one here. Write the following examples using fractions. So they have given statement here. We have to read and understand, and then we have to just write this particular sum in the form of a fraction. If 9 kg rice is shared amongst 5 people, how many kilograms of rice does each person get? So this is the same type of sum which I explained in chocolates. How do we share the chocolates? So whenever there is a sharing, I had told you that time also, when we talk about sharing, what has to be shared should be written in the numerator. Now if you look at this first sum, here there are 5 people and there is 9 kg of rice. This 9 kg of rice we have to share among 5 people. So now what has to be shared? 9 kg of rice. Just write here. As I told you, what has to be shared should be written in the numerator. First, you'll just mention here 9 kg rice is shared amongst 5 people. Therefore, each person gets, as I told you, what has to be shared should be written in numerator. 9 kg of rice has to be shared, goes in the numerator. and the other number will come in the denominator. So each person gets 9 upon 5 kg. Now we are not going to solve this. We are not going to solve this division because the question is write the following examples using fraction. So we just have to write the fraction form of this sum. If they ask you to solve and find, okay, then you can proceed and solve this and convert it into a mixed fraction. Just now how we did. Okay, just now how we did and we converted into mixed fraction. You can convert, but here you have to leave it as it is. The second one, I'll just read the sum first. To make 5 shirts of the same size, 11 meters of cloth is needed. How much cloth is needed for one shirt? Okay, so here 11 meters of cloth needed for 5 shirts of the same size. Okay, here whenever we are writing in the form of a fraction, it is always an equal share. Remember this. So whatever sharing we are talking about, whether we are sharing the rice or whether we are sharing the cloth for the shirt, it is all equal sharing. So therefore they have given that the shirts are of the same size. Okay. So naturally if the shirts are of the same size, they will require same amount of cloth for that shirt. Okay. Now, how much cloth is needed for one shirt? Therefore, cloth needed for one shirt. So here also sharing has to be done. What sharing? 11 meters we have to share among 5 shirts. So what has to be shared? 11 meters of cloth has to be shared. So 11 will come in the numerator upon 5 in the denominator. So here 11 upon 5 meters of cloth is required for one shirt. Okay. So this is the way we write the fraction. Here just keep one thing in mind. What has to be shared should be written in the numerator. So whether it is chocolates which we have to be shared, or whether it is rice what has to be shared, or whether it is the cloth which has to be shared, the numbers for that will go in the numerator. With this we finished practice set 9. So in practice set 9, the first part here, 4th and 5th sum is for homework. Okay. Then in the second part, the 3rd, 4th and 5th sum is for homework. Okay, so these 5 sums are for homework. Rest sums I have solved. So you will write all these sums along with the homework sums in your notebook. Homework. Complete practice set 9 in your notebook. Thank you.